Ujil. I didn't see. Not yet. It's a total like a 10 pass. Hmm? Oh. Okay, na nakitali ni. Mm. Colleagues, good morning and thank you very much and welcome to grade 10 physical sciences memo discussion. And in our midst, we have Ntatenziye. Ntatenziye will be taking us through to this discussion of this memo. And however, ladies and gentlemen, I should say we are also streaming live on YouTube as well as Microsoft Teams. And kindly remember to complete the register. Once Ndatenzi is about to finish, I will also share the register in the chat for you to basically be in a position now to complete the register. Ladies and gentlemen, without wasting any time, let's give Ndatenzi to start with our memo discussion. Ndatenzi, all the best, Menir, and I will be operating from this side as well, just to ensure that we have proper quality in terms of audio and visuals. So with that being said, all the best and enjoy, colleagues.
Good morning, colleagues. Thank you, Ntate Nambani. I hope I'm audible enough. Colleagues, we didn't receive any questions or any problems emanating from question one. So because of that, I think we'll accept question one as it is in the memo, and then we'll take it that it is going to be the way it is on the memo. Now moving on to question two. Question two, it's about waves, sound and light as a combination, but basically for starters, we are looking at pulses and waves. So the question reads as: two pulses M and N travel towards each other through the same medium as shown in the diagram. So we're having that one of M and then we're having that one of N. And then the question, first question 2.1, define pulse. And then a pulse, according to the memo, it is going to be a single disturbance that moves in a medium from one point to another. Now, because there is no underlining or any way that can be removed from that, that means it is going to be a 2 or a 0 for that question there. And then question number 2.2, we start with 2.21, and then pulse length of M. So the pulse length of M, it is going to be 4 centimeters. So the two pulses travel for 4 centimeters along the x-axis in opposite directions as shown and meet. Now the question 2.3, draw the resulting pulse, show the new amplitude and the pulse length. Now for that question, it is 3 marks. Now we expect such a drawing with the labels. Now for the shape, it is going to be 1 mark. For the pulse length of 4, it is going to be 1 mark. And because of what is happening at that point, then that amplitude then will go to 3. So it is going to be 1 for each of the ones that are shown. So we are going to use that marking criteria on your right to go to that question there. And then question 2.4. 2.4, write down the name of the principle illustrated in question, like we indicated in the groups that it should be 2.3. Now that one, it is going to be superposition as a principle. And then the next question, it says there, write down the type of interference that occurs when the two pulses meet for 1 mark. Then it is going to be a destructive interference. Interference, it is in bracket because it is already in the question. So if a learner just wrote destructive, then it is fine with us. No problem with that one. And then question 2.6. 2.6, draw the shape of the resulting pulses after M and N have traveled for 8 centimeters along the x-axis, indicate the direction of each pulse and their amplitudes. Now, according to the memo, and I'm going to mark according to the criteria given. Now, it is going to be such a figure. Now, for both shape being correct, it is going to be 1 mark. For both directions indicated correctly, then it is going to be 1 mark. For amplitude of M, as it is as 4, it is going to be 1 mark. And then the amplitude of N as -7, 1 mark. Total for that question, it is 13. Let's move on to question number 3. Question number 3, it's about sound. Now, it says the diagram 1 shows the sound wave produced by a tuning fork on an insulator.
Thank you, Ntatensiye.
So we are given that diagram there.
Thank you, Ntatensiye.
Okay,
on question 2, maybe I think that is how we should take it. Once you are done with question, then let's take questions, because there's a question now based on 2.1, the definition of a pulse.
Yes.
It's from Helling Matseripe Bahali Ventersberg. I believe it's a cluster. They are asking to say, but now the definition from the exam guidelines of 2020, it says a pulse is a single disturbance in a medium. It does not have the part that says from one point to another. Should we award 2 marks there, or what should be now the case?
Okay, okay, no, okay, no, then let them put that from one point to another. At the pulse, at least there should be something disturbance. Okay, let's see, let's give it a 2. Let's put them that one from one point to another. We'll put it in bracket just for the learners for now.
Thank you very much,
But we have to move on and maybe look at the new shared ones that are already in circulation. But let's take it. It is fine. No problem. It's not a strange measure.
Thank you. And then we have Senfeld. You can unmute and continue with your question.
Hello, hello.
Hello, Mener.
How are you?
We are fine, and you, Tate?
Fine, thank you. I've 2 questions. The question 2.2.2, can we accept the -7 since they used the Cartesian plane? That's the first question. The second one, can we mark positively at 2.3 if the learner made a mistake in 2.2? In 2.2, yeah.
So your question is, are we taking the negative? We have to take the negative.
Yeah, can we mark the -7 as correct? Because all the learners in my class wrote -7. Since they used the Cartesian plane, they only read the value on the y-axis.
Yeah, but the question is clear that we need the magnitude. So the magnitude is always the absolute value of which it is should be a positive, isn't it?
Yes, but they haven't done vectors yet.
Yeah, but okay, no, okay.
Question 3, thank you.
Okay, no, it's fine. And then question number 3. So having those diagrams, diagram 1, it is produced by that tuning fork there. And then it continues to say, diagram 2 and 3 are produced when the pitch and loudness of the sound produced by the same tuning fork are changed. Which diagram will produce? Will be produced at a higher pitch, and you have to explain your answer. And then this is quite a valuable question that can also be used for grade 12 when dealing with Doppler effect. So for that question, the answer, according to the memo, it is going to be diagram 3. The reason, 1 mark for diagram 3, and then high frequency. Underlined weight, it is high frequency, even though the learner cannot say maybe for the same amplitude, but this is what we want the learners to do, colleagues. Every time they have to put, especially when we come to reasoning, it shouldn't be just high frequency. They should go beyond other things that are not changing in that particular case. But for this one, we'll mark only the underlying weights. And then for next question, which is 3.12, by loudness of the sound, explain your answer. Then it is going to be diagram 2. Reason, it is saving a larger frequency for the same frequency. So it is going to be 2 marks each. And then you go to question 3.2. For question 3.2, a man stands between buildings, 2 buildings. When he claps his hands, he hears the echo from building X after 2 seconds and echo from building Y after 3 seconds. The drawings are given as they are, and then the question it is calculate the distance between. For only to us to calculate the distance, we take that given time and then we multiply by a half. So multiplying by half, it is going to be 1 mark. 2 multiplied by 1, it is going to be giving that 1 second, and then we calculate the distance. No mark on the formula for distance, that it is speed multiplied by time. The mark it is on the 330, which is the speed of sound, multiplied by 1, giving you 330. No mark for that one. And then you go to building Y. For building Y, we do the same. Multiplying the time by half, giving us 1,5, and then multiplying it by the speed of sound, 1 mark for that. And then colleagues, please remove this. Shouldn't be this mark here. The actual answer is 495. So no mark also on that 495. And then the next mark it is on adding the 2 distances. The mark it is on the addition. So if a learner made a mistake with the calculation of the distance, but there is some sort of an addition, then we give a mark for the addition and a final answer given there. So, but colleagues, there is no positive marking within a question, and this should be the thing that it is going to happen, that we are not marking positively there for the mistake. We are marking for the answer, for addition of the 2, and then therefore it means if a learner committed a mistake somewhere, then he is going to forfeit a mark for the answer, because there is this rule: if there is a wrong substitution, then there will be a wrong answer. So the mistake that can only be done here with these learners, it is on the substitution of whatever. So then automatically the final answer will be wrong. I think it is clear to everyone that particular point. And then option number 2, we take the same, but we take the whole time for the buildings as the echo is happening. Now the time for X, then it is going to be 2. Now no mark for that 2. and then the distance is still equal to speed multiplied by time, no mark for that. But taking the speed and multiplying it by 2, like in the previous one, we take the speed of sound and multiply by time. There is 1 mark for that one. So magnitude is going to be on the 330 multiplied by 2, giving you 660 meters. And then for the second building, which is building Y, the segments of X, which is going to be half multiplied by 360, and then multiplying by that half, 1 mark, and then multiplying by half by 990, another mark, and then addition, just like in the previous one, that tick should be at the addition mark, not where it is there. And then the final answer, it is going to be 6 marks. I think that is how far question 3 can go. Any questions, any suggestions, any inputs? Colleagues?
Good morning,
Hello, ma'am.
Hello. I just want to make sure a third option may be there at question 3.2, where the kids add the 2 times together and they work out the distance, and then they add the 2 times the 3 plus the 2 together and gives you 5. And then they halve the time 2.5 and then multiply it with 330, and then they get the same answer. How do you award the marks for those 6 marks?
Okay. Marisa, can you just maybe just send it in a WhatsApp, and then we will attend to that one. We'll just edit as an option and then work on it.
Okay, I will do so. Thank you.
Thank you. Okay, ma'am. Thank you very much. Is that all, colleagues? In the absence of any, then let's move to question number 3. We'll also like to have inputs about the question paper, colleagues. How did you find the question paper? Question number 4. Question number 4 is about EMS, electromagnetic radiations. The table below shows different electromagnetic radiations and their corresponding wavelengths. All these radiations move through a vacuum at a speed of 3 multiplied by 10 to the power 8 meters per second. So the learners are given the name of the electromagnetic radiation spectrum, and the wavelength, corresponding wavelengths are given also. Now, 4.1, why are all these waves called electromagnetic radiations? The answer is because all of them are traveling at the same speed. 1 mark. All EM waves can be correctly, colleagues, as long as you are having any 2 correct. That always possesses the wave particle and the wave nature. So that dual nature of light also, it is a point that the learners can also use. So any of the 3, it is going to be correct. Next question, 4.2.1. Write down the name of a radiation that can be used in the TV broadcasting. For that one, the correct answer, it is radio waves. Waves, it is in bracket because it is in the question. And then the next one, used in remote controls, then it is going to be infrared. 1 mark for that one. And then the next question, killing of cancer cells. For killing of cancer cells, we are using gamma rays. And then this one, production of food by plants. Now, plants are using the visible light. 1 mark for that. And then that is that about question 4.2. 4.3, write down 2 properties of the electromagnetic radiations. Now, one, it is originates from accelerating electric charges. They propagate by varying electric field and magnetic field, such that the 2 fields are at right angles to each other and in the direction of the propagation. So that one, it's a very long one, but colleagues, it is what it is there. There is nothing that maybe we can look, but if maybe we find something that we can say is not there, then that learner is going to forfeit that 1 mark. And then the other one, it is electromagnetic radiation travel in a vacuum, and then they all have the speed of 3 multiplied by 10 to the power 8. So the learners have a choice of any two, then we just take any two and then we make it correct there. Next question. Between infrared and ultraviolet light, which one has a higher frequency? Then use a calculation to support your answer. So in order to support the answer, there must be a comparison. So according to this, then according to the calculation, and colleagues, let's try to help our learners to say they should, that one, it is the answer, the first question asked, it is actually a conclusion. So the learners must actually first calculate, and ultraviolet, because it's having a higher frequency than infrared, then it is the one that is going to have a higher penetrating ability there. So that is basically what we are having as maybe the way we should take that question. And then that is 4 marks for that one, and relate it to the ability. There, I know colleagues, learners will be saying penetration is directly proportional to frequency. It is fine because it is all about energy. Let's take it that the Planck's constant will be constant there, and then they can calculate that. Whatever that they are showing that the frequency, it is having something to do with the penetration, then we are going to take it and then give it a 2 mark there. Next question. Define a photon. Now we define a photon as packets of light or energy of light for 2 marks. So in that one, there is nothing that we can say it is going to be 2 or a 0. It is quite explicit, that one. And then 4.6, calculate the energy of a photon of a gamma ray using the values in the table. Now for that one, 1 mark for the formula, and then 2 marks for the substitution, because we are having Planck's constant. Those learners, they should read the Planck's constant from the data sheet, and then from the table they read the speed of light, and then they in fact the bottom, the upper part, it is actually from the data sheet on the constant, and then the wavelength, it is the one that it is coming from the table. So the 2 marks, it is actually a skill of reading from that, and then the next question, which is the answer, it is going to be just a calculation. So that is going to be our 4 marks, and then the total for that question, then it is going to be 20. Any suggestions? Anything, colleagues? Is it clear? Is it fine?
I just want to make sure 4.2.3.
4.2.3.
Yeah, to destroy cancer cells. The memo only says gamma rays, but okay. I know they also use X-rays.
Okay. Okay, no, it's fine. Yeah. No, it is fine. Yeah, it's fine.
And the one about the plant, visible light, UV light due to sunlight.
Yeah, but remember, if we are using ultraviolet in a way, remember during photosynthesis, actually, it is not that high. That's why we're looking at actually the visible light, because that is why we are saying maybe in winter or so, we put the plants nearer the window so that at least it can just get the ultraviolet. So it's a combination that we wanted. It is actually that part of the light. So for now, I have a reservation of accepting the ultraviolet.
Okay.
Okay. Any other colleagues?
Tabang, just say again, do we accept ultraviolet or?
No, we are not.
We're not.
Yes. Okay. X-rays we do accept into 4.2.3. It's fine. Can you move to question 5 then, colleagues? Question 5 is about.
There is a hand in Tate from Wolf Beat.
Okay. Okay,
Hello,
Wolf.
Tate.
Okay, Tate.
Can you hear me?
Yes, I can hear you, Pa.
I just want to talk about 4.2.4 as well for the ultraviolet light. I had a discussion with one of my learners, and they actually learned in biology that because you have the sunlight that comes and is divided into ultraviolet and visible light, they also learned there that the UV light is also um, part of photosynthesis. So we have to, according to me, we have to accept UV light there as well, because they actually showed me some of the work that they did, where they actually learned that UV light is also part of photosynthesis.
Is it?
Yes.
But they didn't.
And I actually. Last night I did a quick search on Google as well, and I found articles referring that UV light is also part of photosynthesis, although it's a smaller part than visible light. But I think we're going to have to accept it, though.
But it didn't say something about infrared, ne?
No, they didn't mention infrared. Only ultraviolet light. That's part of the sunlight, together with visible light.
Okay, no, it's fine. No, it's fine. Let's accept if having maybe a document that is supporting that, and if it is in the textbook, there's nothing that much we can do about it. It's okay. We'll accept it then. It's fine.
Thank you.
All right. Any other colleagues? All right. In the absence of any, then we go to electrostatics. It says there a grade 10 physics teacher demonstrates to her class charging by induction. She uses a polythene rod and rub it with a cloth to charge it negatively. She then brought the rod nearer the electroscope without the rod touching it. That is diagram 1. And then the learner observed that the gold leaf rises. Now, the question is, write down the principle of conservation of charge. Now, the answer will be the net charge of an isolated system remains constant during any physical process. Any physical process, we can put it in bracket, but important, it should be the net charge in an isolated system remains constant. 2 marks for that, colleagues. And then the next question, what is the charge of the disk in diagram 2? Then disk will be positively charged. Then the reason why it is positively charged is as the rod comes nearer, the electrons in the disk will be repelled down the shaft. Then the other mark, it is going to be like charges will repel. So that means there will be that movement of electrons down the disk, and then there will be a repulsion, and then the result is just going to be like charges repel. So it is going to be 3 marks. And then the next question, explain why the gold leaf rises. And that is question in disk 2. The gold leaf, it is rising because the electrons on the shaft of the gold leaf repel. So it is the same thing that it is happening there. So it is going to be repulsion of the electrons which are on the shaft there. And then next question, it is about the charges now. Now the 2 small metal spheres B and C on an insulated stand carries a charge of positive 2 multiplied by 10 to the power minus 6 coulombs and 8 multiplied by 10 to the power minus 6 coulombs respectively. Which sphere is carrying a bigger charge, B or C? The answer should be C. We didn't say they should support their answer, but basically we could have said that. So it is all about the quantization of charge that it is going to happen there. 1 mark for that one. And then the next question, the two spheres are now allowed to touch, after which they are then separated and return to their original positions. Calculate the new charge in each sphere after they have separated, a familiar question. Now we add the two, so it is that sort of a formula. Q will be equal to the sum of the two divided by 2, 1 mark for that, and then putting the two together, the charges as a substitution, 1 mark also, and then the final answer, 1 mark. That's all about question number 5. Any inputs on question 5?
Question 5. Sure. 7. What time?
Nothing. Should we proceed? Question 6. Question 6 is about electric circuits. It says there a battery with negligible internal resistance and EMF of 15 is connected in the circuit as shown below. The reading on ammeter A2 is 0.3 amperes. 6.1, define the term EMF in words. In the memo, we said it is going to be work done by a source per unit charge for 2 marks. Are we comfortable with it, colleagues? Should we pass? Okay. Next question. Determine the potential difference across the 10 ohm resistor for 3 marks. So at 10 ohm, it is here. So what is it that the learners should do? They should be knowing that it is going to be a parallel combination, is their duty, and then that it is going to be equaling to the one that voltage across the 30 ohm is equaling to across the 10 ohm. So according to the memo, how did we do it? We are having 2 options, that the V across the 10 is equaling to V across the 30. So we can just change what we can do the same, that it is going to be 30 and 10. So this one should be 30 on that one, not the other way around. But in both cases, just we are going to rectify. I see the subscripts are not okay in one. So the total, but it is going to be the one that is given. If you look at the diagram here, it is the 30 ohms multiplied by that one there. So all the learners can just work the ratio of the current. It is in the ratio of 3:1. Then they can look into that and maybe also use it as it is. But we are having so many options there that they can use. As long as it is correct, then we are going to get it correct there. That V across the 10, it is equal to that there. So in this first option, they are using that ratio of the current. Hence it is 10-10, then it is fine. And then here they are using the 30 ohm resistor because they're having the current and then that. So in both cases, they are working to the same answer. Whatever they can use, then it is fine. Okay, now we move on to the next question. Question 632, the total current in the circuit. Now, also here, there's some options, any option that the learner can use. Now they have that voltage, it's positive marking from 6.2, they are using that part. Now the total voltage, it is equal to that, and then they calculate, what is the question? I missed something, sorry. Calculate the total current. So the total current for that one, let's check the memo. Total current should be this one, not the previous one, colleagues. 631, it is this part, right? That it is equaling to 9 multiplied by the 10, which is going to be the resistance to, it is the total resistance that we are having there. So it is going to be 3 and then the 6 in the 0.3 and 0.6 coming to this part here. That is what it is happening. So there is no, what is happening here? I'm lost. Am I lost or what? No, I skipped the question. Now I'm surprised. The potential difference, it is 9, which is this one. Now going to 3-1. 3-1 potential difference across R. So your R, it is there. I was lost. It was this one here. Now I was surprised. So we are going the potential difference across that. So we have to calculate the potential difference across the 6 and then subtract it from the 15. Then we get that one of the 9. Yes, the memo, it is correct. So it is going to be the total, which is 15, and then across the parallel, it is 9, and then that R, which is in series, then it is going to be 6 volts. So no, the memo, it is correct. And then 6.2, 6.32. 6.32, we have to calculate the total current in the circuit. Now, for that one also, we can say maybe the total, it is going to get the current, we know the current in the whole, it is going to be 9. And then we just add to the 0.3 to get 1.2, or alternatively, we don't have any that we can use. We cannot use R and get to use the 15 because we don't know the resistance of R. So we cannot use that. So the option that we are having, the best one, it is going to be 632 as it is there. So it is going to be 1.2 amperes of that current there. And then the next question, which is calculate the total resistance of the circuit. Now to calculate the total resistance of the circuit, we have to first find the parallel combination. So we are using combination of the parallel. 1 mark for the formula, 1 mark for the 1 mark for the substitution, and then the final answer. And then, okay, that was the effective parallel combination. So it is 3 marks, and then the total resistance of the circuit. Then it is going to be positive marking from 6.1 and 6.2 and 6.32. So one option, option number 1, it is to say R will be equal to V over T. That is going to be our, that one where we are having the 6 volts that we calculated, and then divide by the total current that is passing through that R, and then it is giving us the 5 ohms. So to the 5 ohms, then we add the parallel, then to go to the total. Or option number 2, which is the easier one, it was to say then R total equal to V total divided by I total, which is going to be 15 divided by 1.2, and then we go to the same answer of 12.5. So yeah, that is that question. And part 1 of charge that passes through the resistor R in 5 minutes. For 4 marks. Now in that one is positive marking from 632. So Q will be equal to I delta T. So it is going to be the current that is 1.2 multiplied by 5 minutes. That means 5 multiplied by 60. And then the total for that, it is 320 coulombs. So that is the amount of charge that it is passing through there. So that is question number 6. Rudolph.
That day, I think you've made a calculation error. It must be 360 coulombs.
How much?
360.
360.
1.2 times 300 is 360.
Okay. So you said it's how much?
360 coulombs. So the question is correct. It's just the answer that's wrong.
That is wrong. Okay, that's fine. 360. All right. Is that all? Okay. In the absence of any, thank you very much for your contributions. As we proceed, question number 7, starting of chemistry. The following diagram, not drawn to scale, represent the heating curve of a certain substance. At point A, the substance, it is a solid. So that's section A there, it is still a solid. 7.1, why is the curve a heating curve? Explain your answer. Now, the answer for that is that the temperature is increasing with increasing time. So that is the reason why it is a heating curve. And then next question, use the information in the diagram to answer the following question. Between which points? Okay, a hand. Mashia.
Didn't see the guy. I just want to go back to 6.1.
Okay, pa.
6.1, I just want to find out if the learner set the maximum energy transfer per coulomb of charge. Maximum energy transferred per coulomb of charge.
Okay. No, it's fine.
Thank you on that.
Okay. Is that all, colleagues? Okay. Use the information in the diagram to answer the following questions. 7.21. Between which point is the attraction force the strongest? Now, it is between A and B for 1 mark. And then number 2, are the particles far from each other and the intermolecular forces the weakest? Now it is going to be between E and F. And then the next one, the forces, between which points is the substance showing mixture of solid and liquid? According to that one, it is going to be B and C, 1 mark for each of those. And then the next question, explain the property of particles at A with regards to the distance between their particles and their motion. So at point A, there, the distance between the particles, it is closely packed in an orderly arranged. So we can see the mark it is on closely packed. And then the motion is particles vibrate only in their fixed positions. So that is 2 marks for that one. And then next question, write down the name of the process taking place at DE. At DE, we are having phase change. At DE, we are having a phase change. And then next question, write down the boiling point of this substance in degrees Celsius, then it is equal to 100. It is 100 degrees Celsius, it is in bracket. So that's why KMT, as it is 8 marks. Any questions? Yes, ma'am.
And if they say you change from a liquid to a gas?
Okay. Yeah, there is a change. At least there are 2 phases mentioned there. That there is one that was a liquid, and then there will be that change into that. So basically, it is a phase change according to that learner there. Okay.
Thank you.
Okay. Any other colleagues? But Marisa, in the process, you must tell the learners that we are not saying explain the process happening there. Actually, we wanted the name. We're specific. Just that I become a bit relaxed there.
And there's also a question about 7.4. What about boiling?
About?
Boiling.
Yes.
Thank you.
Okay. Hey.
That is sorry. I just want to get Confirmation on the evaporation, if you can accept that as an answer.
Where?
That is also 7.4. I think Marisa also asked
why-
that question now.
Yeah, because actually we should have said maybe name. The process, yeah, it is saying it is going to make a room for that as it is moving from liquid going to a gas, we know it to be evaporation, then there will be a chance that evaporation we have to accept because it's a process.
All
I
right,
understand
thank you.
that. Okay. Tademu, I see a hand there was dropped. It's fine. Any question? Any other input, colleagues?
Okay, I'll go back to this question maybe towards the end because it popped in mind for question 3.1.1. So I just don't want to disrupt going back and forth. I'll ask it later.
I can't hear you quite clearly, Tadetwinsi, but
Okay. Oh, I have a question in 3.
Your line is bad. Maybe put it in a text and then we'll look at it in that. I see the cluster there, Khelem Bahali. But that's where you are, Tadetwinsi, isn't it?
Yes, exactly. That's where I am, but maybe let's look at it much later so that we don't go back.
All right, that's fine. And then Aramela?
Yeah, good morning, Minel. I've posted my question in a text about 7.1.
Okay. Yes, sir.
It says Ntatensie from Aramela in 7.1. If Elena says the substance is gaining heat as it was from a solid state, should we accept? The substance is gaining heat as it was from the solid state.
Quite dicey. Because even if it was not now in a solid state, it will never gain a heat or what?
From the curve.
Sorry?
From the curve, looking from the curve, I think.
Or looking from the curve. So the learner is saying is changing from heat, from solid because it's gaining heat.
It's gaining heat as it was from solid, since the temperature is increasing. So the learner did not talk about the temperature. Instead, it just said it's gaining heat.
No, but actually, we have to stick to what it is happening there. Heat is given already, so this learner is becoming a bit not telling us exactly what is happening. He's just saying it is gaining heat, and the heat it is already. Why is it a heating curve? It's because it's gaining heat. No, we need to put it in context that there should be at least some form of temperature being mentioned there.
All right.
And as time proceeds, that is interpretation. What is actually happening with the temperature and the time? It's a graph interpretation.
Okay, Menu. Thank you.
Okay, thank you. Question number 8. If we have exhausted question 7. Question number 8, we can give at least a 1. And then the next question, explain the trend of the atomic radius across the period. Now, across the period, the atomic radius decreases. Reason, the number of electrons increases from left to right. The electrons on the outer shell will be pulled towards the center to attraction force of the nuclear radius. Because of that, then it is going to shrink. So that is basically how we should look at it. So what's happening to the electrons, and then what is going to happen to the force. So that is going to be our 3 marks there. And then the next question, 8.3, complete the table below for substance K and aluminum ion. Write only the question number 831 to 834 and the answer in the answer book. So number of protons, number of neutrons, number of electrons, and then number of neutrons again, sorry. So the answers, it is going to be 19, 20, 10, and 14, respectively. And then next question. In nature, magnesium has the following common isotopes. We are having magnesium 24, magnesium 25, and magnesium 26. The molar masses are given, and then abundance in percentage, X 10.13, 11.17. And then the questions calculate the isotopic abundance X of magnesium 24 for 1 mark. So the learner, they must just know that the total should be equal to 100. So from 100, they subtract the other 2. It boils to 78.7%. 1 mark for that. And then the next question, which of the 3 isotopes is the most abundant? And then give an explanation why are you saying that it is the case. Magnesium 24, it has the higher percentage. And then that is going to be 2 marks. And then the next question, 8.3, calculate the relative atomic mass of magnesium. Now that one, it is going to be the abundance multiplied by the isotopic number, which is 78.7 multiplied by 24, and then 10.3 multiplied by 13, 3 multiplied by 25, and 11.17 multiplied by 26. Now, 78 multiplied by 24, 1 mark, and then the ones that are given already in the table, it is 1, and then either divide by 100 or he adding all those other numbers going to 100. Then there is a mark for that, and then the final answer of 24.32, 1 mark. So the total for that question, it is going to be 4 marks. And then the next question.
Sabong?
Hello, Marisa.
I just want to make sure the learners don't use the 24, they use the 23.985. Is that also okay? Because then they just get 24.48 instead of 24.32.
Yeah, no, it's fine. It's fine. No problem with that. What we want is the skill, and whatever the learners are doing, if it is correct, then it is fine. Just check on it that it is fine. But it is okay with me. Okay. 8.5, write down the electronic configuration SP notation for an oxide ion. An oxide ion, then it is going to be 1s2, 1 mark, 2s2, 1 mark, and then 2p6, 1 mark. So total for that, it is 2, and then the grand total for the question, 18. There we go, colleagues. Is it fine? Marisa or Rolf?
Yes. Thank you.
Okay.
Thank you.
Marisa, you can go first.
No, we're fine, thank you.
And Tati, at 8.2, one of my learners used electronegativity to discuss the question. They refer to electronegativity that also increases as you move from left to right. Can we accept that as well?
Let's look at the question was 8.2. So you said, explain the trend in the atomic necessarily for the radius. We are using it as a way because the way we are explaining electronegativity is the ability of that atom or element to attract or repel. It has to do with another. It has to attract from another, not necessarily within itself. Because already that element, it is there. So it is, we cannot just check it like that. So electronegativity is all about the attraction force that will be existing between two separate. But here we are looking at this one, and then what is happening as we are increasing the number of electrons across, because the elements are increasing. It's not about two different, it is because it is all about one element at a time.
All right,
So we're
thank
not
you.
going to accept electronegativity there.
Okay.
Okay. Any other colleagues? Okay. Let's go to question number 9. Question number 9. HCl is a gaseous molecule. Define chemical bonding. Now, chemical bonding, it's a mutual attraction between two atoms resulting from simultaneously attraction between their nuclei and their outer electrons. 2 marks for that definition. Then the next one, write down the name of HCl molecule. Now here, colleagues, we put it deliberately that it should be a gaseous. So it cannot be hydrochloric acid. It should be hydrogen chloride. And that is the only. So it's either 1 or a 0. No hydrochloric acid about it. And then 913, name the type of bond between the HCl molecule. Explain the answer. Now the bond, the type of bond is going to be a covalent bond. Why? You are having a non-metal reacting with a non-metal for another mark. 2 marks for that one there. And then 921 should have been actually just be 92, not 921. Use Lewis structure to show the formation of ammonia. Now for that one, we are having that structure. So we are using Lewis structures, 3 hydrogens with 1 electron each, and then the 5 on the nitrogen. So 1 mark for each, and then adding the 2, showing that there is a sharing between the 2. It is another 2 marks. So 1 mark it is for sharing, and then showing the lone pair, it is another mark on the. So for that question, it is 9 marks.
The bond at 9.1.3, if they say covalent bond and due to the sharing of electrons.
Yeah, okay, no, it's fine. Covalent bond is all about sharing.
Thank you.
We accept it, but actually the answer that we're looking at is what type of a bond will be formed by covalent bond. So it is going to be formed actually between non-metals and non-metal, but it is fine, Madam Maris. We accept. We just accept.
Tate? At 9.1.2, I know that you said now that we are not going to accept the hydrochloric acid.
Yes.
But when we look at the Afrikaans question, it only mentions that you must write down the naam. And in our textbooks, we've got chemische naam and we've got algemene naam, which actually is 2 different names. So in the Afrikaans, I feel that's not specific enough.
Ja, kan u vir ons die Afrikaans vraag lees vir ons?
Die Afrikaanse vraag sê skryf die naam van die HCl molekuul. So it only it refers to name. It doesn't specifically
There is
say
no,
chemical or general name.
it doesn't make mention of a gas there.
Let's say yes, HCl is a gasmolekuule.
Yeah, if it's a gas, then that means we cannot accept it to be hydrochloric acid. That's why we put that gaseous there. It shouldn't be. It's not any HCl. It's not in aqueous, it is in gaseous form. So if it's in gaseous form, then it's going to be hydrogen chloride. Cannot be hydrochloric acid.
All right, thank you.
Yes, sir. Can we move to question 10?
Yes, it's a tablet.
Ruth, are we okay? Nomlomo?
No, I'm happy we can continue. Thank you.
Okay. Okay, let's go to question 10, which is happened to be the last question on the paper. The diagram below shows the reaction of hydrogen peroxide forming water and oxygen when a suitable catalyst is used. Now, 10.1.1, write down the balance equation for the reaction using the diagram shown above. Now, key to this, it is balance equation. Now, in the memo, it is going to be the way it is. We look for 1 mark for the reactant, and then 1 mark for the product, and then the other mark it is for balancing. So that is how we mark it. So it is as it is there. Next question. 10.12. Is this an example of a synthesis or decomposition reaction? Explain your answer. The answer, it is going to be decomposition. A single compound break into 2 or more simple substances for 2 marks. And then 10.13, does the diagram represent a chemical or a physical change? Explain your answer. Now the answer, it is going to be a chemical change. Original substance is broken down to form new substances. That is 2 marks for that. And then the next question, which is 10.4. Show by calculation that mass is conserved for 4 marks. Now for that one, we have to calculate the mass of the reactants, which is going to be 2 multiplied by 2 for the hydrogens that are there, or the learners can put it 4 multiplied by 1, it is 5, and then 2 multiplied by 16, whatever form that they have, and then that is going to be 1 mark there. And then the other one is calculating the mass of the mass of the reactant. It is going to be 2 multiplied by 16 plus 2 times that plus 16. Then that makes it also 68 grams per mole. So the conclusion there of that the mass for the product, it is equal to the mass of a reactant, it is equal to 1 mark. And then that formula showing that they are calculating the mass of either the product or the mass of the reactant is also 1 mark. The mass equaling to, then that is going to be that what we are referring to there as another mark there. And then the next question, 10.2, it says there 10 grams of sodium hydroxide completely react with copper 2 sulfate according to the following balance equation. So we are having there 2 sodium hydroxide reacting with copper sulfate, and then they give us copper hydroxide, and then X. Now calculate the number of moles of sodium hydroxide that reacted with copper sulfate for 4 marks. Now, for that one, the distribution of the marks. Now we calculate the number of moles of that of sodium hydroxide is going to be the mass, and then we divide it by molar mass, which is going to be equal into 0.25 moles. 1 mark for the formula, 1 mark for each of the substitution, which is going to be 2 marks plus 1 mark for the final answer, 4 marks for that one there. The next question, determine the mass of copper hydroxide produced. For that one, it's going to be positive marking from 9.21. So the number of moles of copper 2 hydroxide is equal to half the number of moles of sodium hydroxide, 1 mark. So it is going to be half multiplied by 0.25, no mark for that. Mark it is on the answer that it is equal to 0.125 moles, and then number of moles equal to mass multiplied by molar mass. 1 mark for that formula, 1 mark for the whole of that substitution. As you can see, actually it is on 125 multiplied by dividing m by 9.5. So that one is for whole of that substitution and getting the mass of 12.19 grams. The total for that, it is going to be 5 marks. And then the question that is left, it is that one. Write down the chemical formula of X. Now the chemical formula for X, the way it is going to be sodium sulfate for 1 mark, N2SO4 for 1 mark. Total for that question, it is 21, and then the grand total, it is 150. This marks the end of our memo discussion, but before we knock off, I think the register is ready, colleagues. If you can just put it, fill it, and then also if we have some other things that we want to look at, we are going to look at. McCry. McCry.
Question 8.
I can't hear you. McCry, can
Hello.
Yes, McCry.
I'm saying question 8.5. I missed how do we allocate the marks there? Can you please repeat that? You said a mark will be for 1S2 and the other mark will be for the whole 2S2 and
for the whole,
2S6, or just
it's for the whole.
The bong,
Right, Patensia.
Tate.
Okay, go back to question 3.1.1 and look at this option, please.
No, there is a
3 point.
Yeah, 3.1.1, the very first one. So the learner chooses the diagram number 3. However, their comparison was based on the wavelength. So the question is, can we accept when learners say diagram 3 because it has a smaller or a shorter wavelength compared to the other 2 diagrams? Shorter wavelength with underlining high frequency as an option.
Okay, no, we can accept it. That diagram is also depicting that. It's fine. That shorter wavelength for the same period.
The bong.
Hello.
So,
I just want to make sure 10.1.1.
At
10.1.1.
10.11.
Yeah, if they get 10.11 wrong, then you can't mark 10.14.
which is most probably
Then they get 0 for 10.14.
10.14.
Yeah, it's a calculation. You say the mass conserved.
You can also go for that. I have
Remember, Marisa, for now, basically, in a way, the Negative marking, it is suspended in a way. So let's mark it independently and just look at what the learner was trying to do for that, and then try to maybe find it, figure it out. Maybe it is just that he didn't balance, so it is going to be not the same. And then because of that, now the conclusion that you will be drawing, because cannot balance. If you cannot balance, you cannot penalize him twice, because what we want, actually, it is just a, excuse me, it is a skill that the learner can do the calculations using the numbers or the atomic numbers that we are having. That is basically what we are trying to test here.
Okay, but
So let's mark it independently.
If he gets something totally wrong, let's say he wrote something like H2O7 instead
No,
of
that will be wrong, because there are no 7 electrons in there. In fact, no 7 oxygens in that. So that is totally wrong.
Yeah, but so if you look at 1011, then it's completely wrong. And now he tries to calculate it 1014, then we're not going to mark.
Yeah, I can give a 0 for that, because really, if it is totally wrong, cannot read what that diagram it is saying. Basically, that's what we are saying. That you cannot see, even though it is there that there is an H, there is an O. We cannot just count the O's and the H's to go to the other side. Now that would be totally wrong. Then, unfortunately, then he is not referring to the oxygens and the hydrogen. Then it is going to be difficult for you to mark. Better just give it a 0.
Okay, thank you.
Yes. Okay, man. Old hand, Marisa.
Yeah, we're okay. Thank you.
Okay. Any other colleagues? Is that all colleagues that we are having? We'll let the feedback. Okay.
That is here.
The notes?
Yes, Menier.
I'm listening.
Okay, Menier. Menier, my question is in 9.2.
9.2, yes.
Yes, the learner, Menier. The learner did not indicate the reaction, but
He didn't show the reaction, but? Motel 14, I can't hear. I see you have raised your hand. I cannot hear what that Mlomo was saying.
Menier.
Yes, sir.
Yes, I was referring to 9.2.
Yes.
The learner did not indicate the reaction, but the learner just wrote the ammonia as a Lewis structure. So how are we going to award the mark for that one?
The question is used to show the formation of ammonia. So he just wrote ammonia. No R, no nothing.
Yes, sir.
What is it that is written there?
So the learner has written the Lewis structure for ammonia.
Without no R, without anything. Mark it independent, yes, just give it a 2, cannot get 4. Because it's just showing us the product. But where is the product coming from?
Okay. No, thanks a lot, Mini.
Yeah. Marisa? Nomlomo again? Are you okay, colleagues? Did we answer all your questions?
Can you hear me?
Yes, I can hear you.
Okay, Tabonga, I have a teacher. We are here at the cluster marking session. And I have a teacher here that wants to ask a question concerning question 10.2.1. So I'm going to hand over to him now. 10.2.2, sorry. 10.2.2.
10.2.2. Okay.
Okay, just here is point, please, Tabong.
Okay.
You can talk.
Good morning, Tadensi.
Good morning, Tate.
That question 10.2.2, the stoichiometry is the term three's work. According to the ATP, it's the term three's work, whereby learners, they determine the number of moles using a balanced equation.
Okay.
So I need some clarity on that. Just
So it's
making you aware.
10.2.2 what you are saying.
Yes, in that.
Okay, no, we'll look into that, and then if maybe there is a problem with that, we'll rework the marks. No problem.
Send me a screenshot.
Okay, that we will send you a screenshot also.
No, it's
Thank
fine. We'll look into that.
Thank you, Tabang.
Any other? Okay.
Mr. Tabang.
Hello.
It's Rion here from Wesselsbron.
Okay.
I have a question regarding 8.4.3.
Yes.
I'm wondering if the learners use the molar mass given in the table, the 23,985, the 24,959, and the 25,983 instead of the 24, 25, 26. Can we accept that? Because it's considered more accurate. I don't know why they did it. Because they've been taught to use the 24, 25, 26. I think because the more accurate molar mass was given, they thought I should use that instead.
So that means that learner is saying the table given is not applicable in a way. The values on the table, you use the values for the molar masses.
Yeah.
As they are, and not the isotopes as they are.
But that is the more accurate molar mass of the isotopes. So the 24 comes from the 23,985. It's just
not necessarily. Not necessarily. Remember, with the isotopes, we are not necessarily looking at the average molar mass as compared to that. So
we are looking at the number of neutrons and protons and not the mass.
Yes.
Okay.
Yeah. So I don't think it is proper for the learner to use that one.
Okay.
Yes.
Because the word relative atomic mass and molar mass, the mass is I think it's because both are masses, they got confused with this question.
Yeah. But the way we have been calculating it all along, even when we teach, I don't think we are using the molar mass. We are using the number of protons and electrons in the substance. That's what we have been using all along. So let us not re-teach them a new concept.
Okay. Thank you.
Okay.
Hello.
Mlomo again.
Hi, Boo. Hello.
Hello. Mlomo, switch your mic off then, if you are not talking. Colleagues, did we take all your questions and concerns? In case you have any other, just put them in the WhatsApp groups with your subject advisors, then we'll address them. And thank you very much, colleagues, for your contributions. We will also just like to get, in fact, I am the one who like to get the feeling of the paper. How did you find the paper? Was it bad, worse, or ugly? Or was it beautiful, pretty, and prettier? Colleagues, how was the paper in general? No comment.
paper was well. The paper was well.
I think
It was very well done.
Okay. So you are satisfied with the paper. So the result will be forthcoming. Remember, grade 10's our weakest link.
Ntalentsiye,
And that.
I think the paper was fair. It went to an extent to ask all the aspects that are there in the exam guideline. So that is why I'm saying the paper was fair.
Okay, thank you very much. Any other input, colleagues? Yes, Nne?
I think the question paper was fair, except that they have already outlined the issue of question 9. That one of
Then,
then
is it 10 to 2 or 9 to 2? I think it is 10 to 2 that you are saying, Nekubeka.
yes. Then otherwise the question paper was fair.
Okay, no, it's fine. Colleagues, I think tomorrow or so you'll get your error analysis for this paper, and then please fill it in so that at least you get a feedback, and then we need to process and try to help where possible with the grade 10s. In the absence of any other colleagues, maybe then let's call it a day. Enjoy your marking in this winter day. Please also, colleagues, fill in the registers. Fill in the registers, please. Mr. Trainers, thank you very much for being there, and other colleagues in the background who make this paper to be what it is, how it look like. Thank you very much, all. And you also, teachers, best of luck in the next discussion that is coming. Hello, Tate. Marisa? Okay. Thank you very much, colleagues.
Ayman.
It